Greetings all and welcome back to Math in Anger. This is episode 35 and we are still looking at parts of one, specifically how to convert from fractions to mixed numbers to decimal numbers, and in this case specifically repeating decimals. Right. Here I'd like to show you I'm still doing exactly the same thing. I go and write my product, 5 zeros, my additive, I do the long division, and there we go. But I want to point out this pattern. You see there, 4 with a bunch of following zeros, 4 following zeros, 4 following zeros, 4 following zeros. This pattern continues indefinitely. It continues forever. Literally forever. It does not end. The way we write that using the decimal number system is this way: 0.16 with a line above the 6, and that line means this 6 never ends. It is repeating forever and ever and ever and ever and ever. And what I'd like to point out to you is this representation, what we wrote here. It is 100% accurate, 100% complete with respect to the value that you are thinking of when you do this calculation. This over here is a rounded value. It no longer 100% correctly represents the thing you are thinking of. This is complete and accurate. This is not complete. It is not 100% accurate. Okay? And now I'm going to show you something that might shock a lot of you. That is a calculator. Look at what happens when I ask the calculator to do this. Do you see that the calculator is rounding? Yeah. There is no calculator or computer in this world that has enough space to be able to represent that 6 an infinite amount of times. They all stop. In fact, most calculators and computers can't even tell you that this is a repeating 6. They all round. You have to be aware of this problem with both computers and calculators when you progress further in mathematics. Beyond school level, know this. Your calculator is always rounding. It can't even tell you that this is a repeating decimal. Some of them can, but they are ridiculously specific and more often than not ridiculously expensive. Your calculator is just a tool. You can do things, you can think about things that no calculator can represent. Okay? Here then is another example with 2/6, and yes, most of you will tell me that's just 1/3. You're absolutely correct. This is just an example. Again, I took my product, I wrote it down, I took my additive, I did the long division, and here again we have this pattern. And this pattern continues forever and ever and ever and ever and ever and ever. Echo, echo. Yeah, it goes on forever. And here again, we write that value using this notation. 0.3, the line, that means repeating. The 3 carries on forever. And this again, it is just a rounding of what we are thinking of. It is no longer 100% representative of what it is that you are thinking about. This is important, guys. What we have written here 100% represents what you think. What we've written here 100% represents what you think. Okay? This distinction, I'm hammering on it because we're going to arrive at a point where we're going to see that we can no longer write what we are thinking using the decimal number system. But in order to explain that, let me fetch another example. I need to clean up some space here because I am going to need quite a bit of space to show you what I'd like to show you. And while I'm doing this, I'd like you guys to whip out your calculators and ask your calculator, what is 1/7? In other words, what is 1 divided by 7? Go ahead while I'm busy doing this and cleaning up space. And I'm fetching the example. What answer did you guys get on your calculators? Here we go. Is it different to what I've got written here? Most likely, because your calculator is rounding. Right, now take a look at the pattern here. The pattern isn't immediately visible when you're looking at the long division, but when you look at your result, the pattern becomes visible. 1 4 2 8 5 7, 1 4 2 8 5 7. And this again, that pattern repeats forever, and this is how we write it: 0.142857 with a line above the complete sequence of digits that repeat. Again, what we have written here, it is a 100% accurate, 100% complete representation of the value you are thinking of. Take a look at what happens when I ask the calculator to do this. Do you see the calculator stops? It goes and rounds the result. Again, guys, mathematical notation and mathematics are not the same thing. Mathematical notation has points at which it fails. What you are looking at here is the point at which the decimal number system fails to represent the values that we can think of. I am mentioning this now because we're going to get to a point where I need to explain how we represent values that cannot be represented using the decimal number system. Yes, they exist. Right. Then again, please, people, you do not use a hammer to drive in a screw. You can, but it's going to be messy. Or you can try at least. Thing is, your calculator, it is just a tool. You have to know when your calculator fails. You have to know what its limits are. And this right here is where it begins to fail you. When you start going beyond school, and if you're not aware of this situation hits you like a brick wall. Right. Anyway, this then was Math in Anger, episode 35. I will see you in the next episode. Ciao.